Hello.
Hi, everyone. So, just to repeat that, unfortunately, David, not this David from France, but another David, he should have done a session about Elastic and the Hive, which we would have loved to have. Unfortunately, he got sick, so he cannot join us today. I think he lost his voice. Nobody would have enjoyed that. And we hope for a great session instead with him at one of our upcoming meetups then. To not have like nothing or some surprise session or whatever, we thought since there are enough questions on chat anyway, we'll just have an AMA session together. And I would just say like we pick one very common question that we always see ourselves. And after that, we dive into your questions. And I'll try to not do any work. I'll just give stuff to do to all my other colleagues. So with me, I have Alex, Aravind, and David, all developer advocates at Elastic. So let's dive into it. So the most common questions that we normally get is like, what is the right shard size that we could or should have? And it is highly debated and sometimes controversial. And I'll leave it to the three of you who wants to answer that and how to answer that.
Yeah, I'm happy to go ahead here. I think the most common answer, even if you've ever attended a training at Elastic or probably a talk from one of us, is always it depends. And that also yields true for shards, because in order to understand what shards are actually doing, you always have to take a step back and understand what a shard actually is. And like most of you will have read, it's an Apache Lucene index. And that one takes a certain amount of resources. So the basic idea is always to have the shard as big as possible without running into issues, so that it probably cannot be held by a single node anymore. And it still needs to be moved around, right? You have a distributed system, which means you still have probably to move data around at some point in time, imagine a rolling upgrade or an outage or adding a new node. So all of this requires you to move data around. On top of that, there's also a difference in reading and writing in terms of the perfect shard size. If you write data, you prefer to fan out all your writes on all of the different systems so that you can write more data in parallel. Whereas when you try to read your data, you usually try to do the opposite and like read from as few shards as possible. So you have less reduce or query and fetch, it's called in Elasticsearch, less of those times. So there's lots of different things that come into play here. And you may have heard of ILM, and I already saw a question about that in the Q&A as well, Index Lifecycle Management, where you can basically change also the number of shards and where your data is, depending if you have differently sized nodes, so that you make sure you write the hot data with the highest speed possible, whereas you basically, when you start reading less important data, you have this on a so-called warm tier where things are not written anymore. Data is not written anymore, but it's merely read, but you still read it pretty often. And then you age out your data. That, of course, only works if you have something like time series data, which is a really common use case. And then on top of that, you have a cold tier where you basically try to reduce the resources you need for your data, and a frozen tier. And you may have heard about something like searchable snapshots that will come out in the future, probably in the next release. And those searchable snapshots allow you to even search in snapshotted data in a remote repository like S3. And coming back to the original question, so the original shard size is not only about data, but it's also about searching, right? Like when you search, you always basically search in sequence within a single shard. So it may also be advantageous if you have several shards searching at the same time. And coming back to our original question, with all of this in mind, so you already see like just coming back to you with a size where we say like, this is the perfect shard size without knowing your query load, without knowing your write load is really hard. But keeping shards usually means you have a size like 10, 20, or even up to 50 gigabytes. But at some point, it really gets hard to move these parts of data around. And I hope that was a not so quick answer about this topic, but it's a complex topic, and even such a small question may lead to a really long response.
Right. One question I think that ties pretty well into that right away is Nomi asked, do you have a specific license type to be used to use a searchable snapshot that was added in 7.11? So the license type that you need, searchable snapshots is not one of our free features, but it is one on the tier that we call enterprise. So it's not freely available because it changes the characteristics and like our entire pricing model otherwise. So it's not one of our free features, but that is one of the paid features in our stack. Those who have never heard of searchable snapshots, it's basically you take a snapshot and just use it from the snapshot rather than having it on like an active or hot node. So you could just run or put the snapshot on Amazon S3 and then retrieve the relevant pieces to actually serve your search results from that rather than having it all on a hot node. Okay. Next up, question-wise, I saw one about Logstash and the JDBC plugin that space keeps increasing as you add more documents, even though you seem to be replacing them. Alex, do you want to go into or explain a merge strategy in Elasticsearch?
Absolutely. Not only merge, but I think it's also important to take another step back and understand how Elasticsearch actually is writing data. And in order to have a fast system, one of the things you don't want to do is do in-place updates, because in-place updates usually means you either have to move data around or you need to have some sort of pre-filled space for this data. And the idea that Lucene, the underlying library within Elasticsearch, is actually doing is that it creates so-called segments, and those are immutable. So when you write a new data, you always create a new segment, and it's kind of an append-only mechanism. This has one advantage. And the biggest advantage is that you can do so-called log-free reads. So you're absolutely not dependent on any other writing component in order to read your data. You will always be able to read your data. But of course, this comes at the expense that you need to have some sort of cleanup mechanism over time that basically ensures that the data that is not needed anymore, like deleted data, gets cleaned out. And this is basically what Philipp just mentioned at the beginning, what the merge operation is doing. After some point, if like in your example with Logstash and JDBC, you keep writing the same data, what you're basically doing is you mark the old document as deleted and create a new one. So over time, you create more of those old documents, and Elasticsearch has a built-in mechanism that it basically cleans those things up. And this is the merging that Philipp mentioned earlier, in order to make sure that those deleted documents really get removed from disk and they're not only marked as deleted. And this is basically something that kicks in automatically in the background if you wait some time, but you can also trigger it yourself by calling an operation named force merge. Also, you could configure this to only delete the documents that are marked as deleted. So you can trigger this yourself, but usually Elasticsearch should do this as well. This is also configurable, but I would always consider that an export option.
And I hope that was the question, because that was my interpretation of the question. If not, please drop us another note in chat and we can follow up. It should generally be more or less independent of what Logstash does, because Logstash is just like moving data from the relational database into Elasticsearch in that case. And then like that the space keeps like growing up and then shrinking down a bit again, hopefully afterwards if the merge kicks in, is just how Elasticsearch works with that. Another question that we had was about if our Elastic APM agent for Java supports Kafka and reactive systems. And yes, they do. And I think I'll just drop probably the right link in chat afterwards. Or if you search for it generally, we always have for the APM agents, we have a page like supported technologies, and they list out all the systems that we have. And since they evolve quite quickly, I also have a hard time keeping up to date all the different pieces of things that we support today or in the next version. So it's probably the best idea to just go to that page for the supported systems and then check, these are the things I have, are they all supported or not? And then you can use them. Also, just as a small side note, with OpenTelemetry, which is kind of like the more standardized approach nowadays, we can ingest that into Elastic APM and Elasticsearch and Kibana as well. So if there are features that are only supported in the OpenTelemetry APM agent for whatever language, you could also use that one instead. Though we could have a deeper discussion why we think that our agents still have their own advantages, but they don't necessarily support all the technologies. So if you have something that might be a blocker, you could just use the OTel agent instead.
Yeah, I think just as a quick side note, the question was about Reactive Spring, like I suppose that is Spring Vectflux, and I think this is still in the works for the Java agent.
Yes, it's also not explicitly listed on that page. Aravind, did you pick your favorite question?
Okay, so I was looking at this question. We have a very large daily indices, and that would be handled nicely by ILM. And then am I hindering the performance by only allocating one primary shard or write point for each rollover index, as opposed to allocating six initial write points at creation? I believe this is a question that has multiple topics as well. Wherein you have ILM, you also have something around the performance of the cluster. I mean, how do you think, like, you should take an answer? Like, Philip, do you want to answer that?
So, sorry, what was the question again?
Okay, fine. So it was about ILM, and then it was about, like, they have a large amount of daily indices that are properly created. I mean, they have proper ILM processes which would handle the rolling over the data. But the question is about the performance of allocating only one primary shard for each rollover index, as opposed to allocating more initial write points, like more primary shards, like to do more of this rolling over operation. That's what I even got from the question.
I think that also ties back a bit to Alex's initial point about, like, the size of the primary shards, that when you want to have many writes in or then you want to parallelize your write performance, whereas afterwards for your reads, you might use the now available shrink, or I mean, it has been available for a couple of years by now, but depending on how old your systems are, the shrink API, where you can actually reduce the number of shards. Just remember, shrink is always by a factor, so don't pick a prime number for the number of primary shards, because the only place you can go with a prime number is always 1. So the old default of 5 primary shards didn't give you too many options for that, so you could only shrink down to a single shard. Whereas if you pick 4 or 6 or whatever, you would have more options to have a more flexible shrink schedule to run afterwards. Yeah, so that's that for ILM. And ILM also, if you have any questions about, like, why is my policy being used or not used, ILM has a very nice explain endpoint as well that can tell you why you're in a specific phase in ILM. Because while ILM is doing a lot of magic for you and solves a lot of issues, it can also sometimes be confusing, either because you ran into some edge case, or you set up something that is, for example, cannot be satisfied. For example, you set an allocation policy, like this specific index needs to be allocated on a node with a specific attribute, and then you didn't have enough space on such a node. And then your ILM policy, of course, would get stuck. And with an explain, it could then tell you why is it not actually allocating or moving through that ILM phase, and you're stuck on something for an index. So with that API endpoint, you can actually very nicely debug, like, why is my ILM working or not working or moving as it should. Cool. Favorite next question?
Yeah, I would probably pick one. I think this is something that we didn't look at. Like, this is a question from Deepak, who says, like, he uses Firebase for his application, and then but there isn't any full text search feature in Firebase. And then is there any search solution specifically for people building with Firebase that Elastic could provide? So I think this is pretty straightforward, because I did work with Firebase, and, like, I did create some apps, and I would definitely like to answer this. Say Firebase is also a NoSQL data store, and then you could probably use it with a mobile, mobile app as a backend. Firebase is a platform. I have specifically I've seen people moving over to Elastic app search, or if there is if it is an e-commerce or an application which requires a lot of query side optimizations and improvements, or if you want to calculate something like some specific metrics all around along with some some good full text search analysis, then you can use the raw Elasticsearch. But other than that, we have a fantastic solution called App Search. You should definitely take a look at that, because App Search would definitely solve the relevancy problem, make it easy for you to get started pretty much quickly, and also offer that full text search capabilities to build even in React, if you're using a React sort of framework on the mobile side. Yeah, so that is those are the two areas that you should definitely look at. Right?
Cool. Alex, can I bump you to the next question?
Yeah, I can just go on with another APM question that just came in. There's a question. I'm testing Elastic APM with Node.js and Express, which is a kind of common Node.js-based web framework. In the transactions list, I don't see the database steps, and I'm using an Oracle database. Is it okay, or should I have some changes in my source code? And it's insofar expected behavior because there's no automatic instrumentation of Oracle in that case, whereas it works for Postgres within the agent. What you could do as a workaround is, however, to use the library and implement your own spans around that. And that would be what you need to do as long as there is no automatic instrumentation added for that. There is a dedicated issue in the APM agent Node.js repository. So please add a comment to that. There will be a feature for you to have.
And I see one of the last questions we got right now is about the optimum pipeline workers, heap size, core count, and what all of that, how that impacts performance. And this is, I think, where we can bring out our favorite phrase, which is "it depends." So normally, I know people hate this question or this answer, and it's normally what you answer as a consultant, and afterwards you charge a lot of money. But why do we say it depends? Because, well, it's not that simple or straightforward to say, oh, you do this and then you have that. Unfortunately, in a more complex system, you have many pieces influencing it. So it will, of course, depend on like how many documents are you processing, but also like how large are those documents, or how complex are they? How complex is your mapping? How complex are your Injust pipeline steps? So if you just drop one field, that's much simpler than if you run a more expensive Grog pattern on a very long substring. So it's very hard to say like you will need this hardware and then this will just work and perform. The only way to actually properly figure this out normally is that you have a representative test set and that you try out what can you do with your specific hardware, your operating system, your configuration. And then you say, okay, in reality, I will have like 5 times the amount of that data. So I need 5 times that hardware, or the latency that I get out of this is X, and maybe X is okay, or X is already too large, and then you need to change it. And then you can either throw more hardware at it, which is kind of the stupid approach, but it's also very efficient in many times, or just cheap in comparison to actual work. Or you just need to start like rebuilding your Injust pipeline to see if that makes sense. We also have 2 talks actually about performance later today. So one is coming up pretty soon. It's about Rally, the tool that we wrote. It's kind of like the performance measuring tool that we use a lot internally, but also people use it externally quite a bit by now to set up a test cluster, then build a representative data set, and with Rally play that through so-called Rally tracks to see how their system will actually behave. And then there is another load testing talk later on in the day, I think in the more Americas time zone, that is not using Rally, just to give you a different approach, but that like, what is the amount of hardware I need, or what is the latency to expect? Those are very common questions, but there are no simple answers. And we're not trying to get out of the question, say like, it depends, go away. But it's more like, it depends because of these things. And then you need to do these other things with Rally or whatever you use to test to actually figure out what makes sense for your hardware, your documents, your update frequency, your read frequency, the refresh rate that you have set. There are so many variables that there is no single answer of what will perform well or what will not perform well. enough rambling from me. Alex or Aravind, have you picked another favorite question?
Yeah, just to maybe reiterate for the last question, because it mentions logstash and the Grog filter explicitly. The Grog filter is basically a list of regular expressions being passed, which is inherently CPU intensive. So if you can get rid of this Grog filter, maybe by taking a look at the dissect filter, you will probably already be able to save a lot of CPU. And yes, adding more cores would definitely make this more parallelizable, or adding bigger cores would make this faster in this example. And like 6 hours delays for logs probably is a lot in that context. So I think it makes a lot of sense to dig deeper what is actually causing this delay in this specific question.
Okay. So I have looked at another question like related to Injust Pipeline, like Philip, you mentioned about Injust Pipeline. Like I think we do have a UI in Kibana, which is how do you construct some Ingest pipelines, but we don't have a visualization around it, like how Ingest pipelines work, like log stash pipelines. That's a nice ask actually, and probably like we will definitely take it back. And then as of now, there is not isn't something like around visualizing the Ingest pipelines itself. So, but that isn't something that we could take back as a feedback. Thank you for asking that.
Another question that I've just seen is from Samia, who asked about CCR or cross-cluster replication. So just that's probably also a good reminder. One Elasticsearch cluster should always be in one region, not necessarily data center. So if you are on one cloud provider and they have multiple availability zones and they have data centers very close to each other, then you can span a cluster for high availability across that, but it should not be across a region. So a cluster should, for example, not span more than one region from a cloud provider or your own data center if they're apart by 100 kilometers or so. That's definitely not recommended. So for disaster recovery scenarios, you might want to have another copy or version of your data in another data center. And that's exactly what cross-cluster replication, I'll stick to CCR because that one I can say, what you can use. So what CCR basically does is there is the leader cluster and the following cluster for leader index and following index because it's on a per index basis basically. And the follower will basically pull over the data as quickly as it can. So it doesn't add latency or anything in your actual queries because it will be pulled over asynchronously. But it will be almost up to date and our monitoring will keep you on top of like how much delay you have. So that's kind of like the solution that we have built officially for multi-data center support. So CCR will give you the option to have one index in this data center and maybe another index in that data center, and both are live. And then you kind of like pull each of them for disaster recovery into the other one as well. So you have another copy that is there read-only. You could promote it to be a proper write copy if one of the data centers disappears. And that is what CCR can do for you. The question also asked, like, is there a light version of that or anything? Not really. Maybe you could build something yourself. For example, if you have a queue like Kafka and you just throw every document into the queue and then the queue kind of like sends it to one data center and the other data center. But that's kind of like fully outside of our stack and not managed by us. So if you want to have the disaster recovery scenario with multiple data centers, CCR is our official solution. Though since this is more of an enterprise feature, is also one of the paid features that we have in our stack. That's the official solution. Otherwise, you would need to build something yourself, maybe with a queue or whatever makes sense for you there. Yeah, that's the CCR question I see. We have like 6 minutes left or so until the next talk. Maybe we can do either 2 quick questions or one longer one. Who of you wants to go first?
I'll go first, actually. So this is about that question wherein like a user wrote about like we are indexing 5K documents per second, and then when we try to execute queries on while the documents are indexing, it takes 30 seconds. So this is some standard issue that I have seen. You can configure clusters in either say write heavy or read heavy or a hybrid approach. So there isn't one point like in the from the beginning we've been saying that there isn't one point solution to a lot of these questions. Probably we need more data to look at. You could definitely write, ask us more about discuss.elastic.co with more parameters, and we could probably converse, or Slack community. At the same time, you could go and turn on the stack monitoring feature, which is there in Kibana, so that you will get what's happening, and how your shards are responding, or have some metrics around what's happening in your cluster when some things are happening. When some things like, those spikes or queries that are taking more amount of time. So these are some standard tips that we could give, best practices that we could, talk about. But end of the day, to specifically pinpoint, we need more data, or we definitely need to understand the more better use case. So that's what I would say. Like, just think about how do you configure your cluster for having a hybrid use case, like, wherein you have decent amount of, like, writes, and like you are looking at a specific time period where you want, you have a lot of queries coming in, and then you want to balance it out during that time. You could configure the cluster to load balance at the time. There are many strategies. So just read about these, or like, ask us in the Discord. That would really help. Yeah.
Alex, final question for you.
Yeah, let's take a quick one so we can proceed. Kevin asked, what would be the best case to enrich events when you propose an ingest pipeline with the ingest node, so within Elasticsearch? Do I have to replicate the ingest in Logstash? And I think the question here is about like further enrichment against another data source if you want. In this example, this is a key value with memcached. If you take a look at the existing ingest processors, there's one that is rather recent and was released within the 7X series called the Enrich processor, which basically allows you to execute a query within the processor against another index within Elasticsearch, and then take the answer from that one and put it into the document. And that probably might be sufficient, so that there's no need for you to query another or second data source in that context. And just make sure that you keep updating the data in the index that you get the information from, and then use that one within your ingest pipeline. All right, I think that's it. And Philip, we will probably move on.